Let's go ahead and begin the practice exam. Second one, problem 1. So we want to know the speed of the buggy at 2 seconds. We calculate the slope because the slope is the speed, and when you do that, we should get 25 minus 0 over 5 minus 0. That's going to be 5 meters per second. Now, where did the buggy start from? Its initial position is 0, which we read off the graph. For part C, how far did the buggy go? Well, we read it off the graph. It went 25 meters. When we plot the velocity versus, and we describe the motion of the buggy, moves forward at a steady pace and stops after 5 seconds. When we want to plot the velocity versus time, we up to 5 seconds go this fast. You know what? Let's use a different color. So we up to 5 seconds, we go at 5 meters per second, and then 5 seconds to 10 seconds, we're perfectly at rest and we don't move. So that's question number 1. Moving on to question number 2, we have these two buggies, and we want to see what's going on here. So we want to know when and where they hit. Let's actually write down the equation for each buggy. So buggy A x is 20 times t. Now buggy B, this is interesting. For buggy B, it's actually delayed by a second. So it actually, I don't like that color. I mean, I like that color, but not for the buggy problem that we're doing here. Let's use this color. So for buggy B, x actually ends up being so we can write this as negative 30 plus t, negative 30 times plus 200, but we got to be clear that we're actually delayed by 1 second. Okay, so there's some math that we could do, but I'm just going to write the words plus delayed here. I'm not going to add something this hard to your exam. I'm going to do a little bit differently on your exam, but I wanted to kind of do a little bit more of a challenging one since we are in honors physics class. So we want to know when and where they meet on the ruler. So what I want to do is, in fact, record here what's happening with this, where here's what we'll do. We're going to let 1 second pass for the first buggy A, and then we're going to start moving buggy B. So at 1 second, at t equals 1 second, to get them on the same schedule, we could write buggy A as being at 20t. That's still its speed times its time. But now 1 second's passed, so it's at the 20 centimeter point is kind of the new way of looking at it. Now when we solve for t, this is 1 second less than the clock actually reads. So now these will be the two equations that we set equal to each other. So we can actually solve and say negative 30t plus 200 equals 20t plus 20. We'll end up getting 50t is 180. So t is 18 over 5, and when we get that time, that's going to be 3.6 seconds after buggy B starts. So 4.6 seconds when they meet. Let's actually get that position, though, using the Buggy B equation. So where they meet, x is going to be negative 30, but I'll got to be careful here and use 3.6 because that's the only amount that it covers, plus 20, and that's going to end up giving us they meet at the 92 centimeter mark. If we want to graph this, this should be interesting. Let's see, 1, 2, 3, 4, 5, 6, 7. Oh, that's cute. 1, 2, 3, 4, 5, 6, 7. That's going to be the time in seconds. And then this position. Oh man, it's going to be messy. Whatevs. We'll see what we do here. So 20, 40, 60, 80, 100, 120, 140, 160, 180, 200. Look at that. Let's shrink this view down so we can see it a little bit better. That's good. Isn't that cute? So there we go. So 20 centimeters, 40 centimeters, 60, 80, 100, 120, 160, 180, 200 centimeters. And this is, again, position in centimeters. Let's go ahead and get those plots. So here, we've got x is 20t for Buggy A. We'll plot its original plot. So 20 times t, right, 4, 5, 6, is that right? So 20, 40, 60, 80, 100, 120. Sorry, this should say, I numbered these wrong. Let's just double check these numbers. This is going to be 140, 160, 180, and 200 right here. Sorry about that. And then one more for Buggy A. Sorry, 160, 180. All right, there we go. Sorry, 7 is right here. Let me just get rid of all these little dots here. This is where this is where the 7. This is where the Buggy is at 7 seconds when we're talking about Buggy A. And then here, let's go ahead and let's actually get that line plotted. No, I don't like that. Okay, let's try this. All right, fine. We'll go this way, down through here. There we go. So there's one. Now let's get the other Buggy graph plotted. Now it starts at 1 second delay, so we're actually going to start it at 1 second delayed, negative 30t plus 200. But since it started after 1 second, its plot actually looks like this. So its plot looks like this. It's still for 1 second. And then after 1 second, it goes 10, 20, 30, 10, 20, 30, 10, 20, 30, 10, 20, 30, 10, 20, 30, 10, 20, 30, like that. And then we can actually connect the line here just to get it connected. And whoa. All right. So we end up at the 90. If you actually look here, this is a really good plot. If we use lines like this is really at 4.6 seconds and 92 meters. So it really does confirm our results. And that's question number 3.